Okay, you might want to go ahead and try this next problem on your own, but if you get stuck on it, you can watch me work it on this video. We are going to have very similar to the last one. So we're going to do 7x times 10 because these are, the products are equal, and then 15 times 5x minus 2. And then that means I have a 70x equals 75x minus 30. At this point, subtract 75 from both sides. So that will give you a negative 5x equals negative 30. So dividing by negative 5 leaves you with the value of x equals 6. And once again, sometimes they'll let you stop with an x equals 6, but you could always plug it in if you needed to and figure out that that's 42 and that this would be 28. So you can always substitute in if that's what the problem asks. Okay, let's go ahead and look at these down at the bottom. On the next one, notice that these chords are the same distance from the center, which means they're equal. If the distance from the center is equal, then the chords are equal. So you can start with a 5x minus 2 equals a 3x plus 2. Subtract 3x from both sides. So 2x minus 2 equals 2. Add 2 to both sides. So 2x equals 4. Divide by 2, so x equals 2, which is absolutely wonderful. Now, in this problem, it also wanted you to find the radius. Well, to find the radius, you're clearly going to need to substitute in. So if I substitute in the 2, that's going to be 3 times 2 plus 2 is 8. So what I have is that whole chord is 8. But then to find the radius, I'm going to need to draw in the radius. So I'm going to draw in a radius right there so it makes a right triangle. So now I have this right triangle, and I know this side is 3. I know this side here is 4 because remember, if this is a radius, it is part of a diameter. And a diameter would bisect that chord, so that chord is split in half. So the distance to the center is 3 for that leg. Splitting the chord in half, half of 8 is 4. And then to get the radius now, I'm ready to use Pythagorean theorem. So 3 squared plus 4 squared equals my radius squared. I could call that c if I wanted to. That's 25 is r squared. So my radius is 5. So that shows you how you can solve for x, plug it in, and then even go a step farther to find the radius. I recommend you pause the video and try this next one on your own. But if you get stuck, you can play through the video and I'll help you. Okay, on this next one, since the chords are equal, the distance to the center is equal. So I have 4x minus 5 should be equal to x plus 4. Subtracting x from both sides gives me a 3x minus 5 equals 4. Adding 5 gives me a 3x equals 9. And then dividing by 3 gives you an x equals 3. Now, once again, if you're going to find the radius, you're going to need to take this 3 and plug it in. So it doesn't really matter which one I plug it into. 3 plus 4 is 7. Or 4 times 3 minus 5 is also 7. Clearly, the distances should be equal, so you could get the same thing either way. So this length here is 7. And then remember, since this is part of a diameter, a radius is part of a diameter, it will bisect that chord. So that means this side here is 10. And then draw in your radius, and you're ready to use Pythagorean theorem. So I have 7 squared plus 10 squared equals r squared. So that is 149 equals r squared. And r equals the square root of 149. And I don't think that's going to simplify too well, so you're just going to have to stop at square root of 149, or you could put it in your calculator and be 12 point something if you needed a decimal approximation. But that's how you can use these problems and go a step further by plugging them in and getting the radius.